Hi, I'm Maren Leed, the Executive Director of the National Spectrum Consortium, and I'm here today for a conversation as part of our Spotlight Series discussions with our members to highlight their capabilities and hopefully facilitate greater collaboration amongst our membership. So I'm thrilled to be here today with Ryan Luther, the co-founder and CTO of Windtalker Innovations. Ryan, great to have you.
Maren, great to be here. Thank you.
So can you just talk a little bit quickly about your role at Windtalker and some of the ways that you spend your day-to-day life?
Sure. As CTO, I basically oversee all of the research development and testing of our product lines, which currently is Osmosis as a network, and also some planner and manager products that we have to be able to plan a network and then be able to monitor that network to include network health, device-to-device connectivity health, as well as device health itself. And we've also, out of necessity, built some hardware as well that we have offered. And I think one of the things that is interesting is we're a software company, so we want to stay rooted in software. And one of the things that I think NSC offers is great partnerships for those sorts of things that we've had to build out of necessity that we don't necessarily want to productize.
Well, so you guys are about 5 years old, I think, and have kind of an interesting origin story. Can you talk a little bit about how and why you and Matt Purdue, your co-founder, started Windtalker and kind of what your experience has been like over your first 5 years? Congratulations, by the way.
Oh, thank you. Yeah, so we were both in the Air Force and retiring. And as we started looking at the commercial space and trying to decide what we were going to do, Matt was, I think, about 4 to 6 months in front of me in retirement. And he was actually traveling back from an interview. And he was stationed in Alaska at the time and was flying over Canada, and was like, why is the go-go connectivity so bad? Right? Why is it that I don't have continuous connectivity, and why is it that when I am connected, the performance is so poor? And one of the things that we did in our past was requirements for the Air Force and a lot of system integration and network architecture. So it's funny, it started a conversation literally from a bar napkin that he drew on in flight, and really took about 6 to 9 months to maturate to the point where I woke up one morning, I'm like, I can't not have done this, right? Not have tried, because we really took the initial concept that Matt had of, hey, we've got an airborne mesh in the military and everybody can connect up, and we've worked on building that type of network over decades. Why don't we have that in the commercial side? And we really took that and started applying it. And by the time we had created what we think both commercial and government really needed, it became a multimodal network of networks to bring disparate networks and protocols together. And was so exciting that there was no way I could look back and not have done this. So we're excited to be 5 years in and really look forward to the future.
Well, so you mentioned Osmosis, which is sort of your primary product line, I think. Can you tell me a little bit more about what Osmosis is and sort of what some of its unique capabilities are?
Yeah, absolutely. So Osmosis, first and foremost, is software. So software-defined network, we like to call it a cognitive network. We also refer to it as an over-the-top network. But basically, with a software download, it transforms a normal device into a device that can connect with other devices that have that same software download. So a lot of times, to put it in perspective, we like to talk about what everybody has in their hands or on their person usually, which is a smartphone. And give the use case of, if you want to send a chat to somebody that's even in the same room as you, currently, you have to have a network provider cell tower within line of sight, right? That message goes out to that cell tower. It fights against resources to the cell tower. It then goes across a fiber network where it's again competing against resources to get to the internet, to the server for that application, right? And then that server will then redirect that information down, all the way back down, competing against other resources to the person in the room, where Osmosis allows you to really keep things at the tactical edge. And I know in a commercial sense, they call it MEC, right? But really, Osmosis allows you to build those edge cases where now you can go direct cell phone to cell phone and have that communication. You can enhance and extend existing networks as well, so that if I have a kind of connection to a Wi-Fi access point, a cell tower, a satellite, or even something in RF, I can now extend that capability, extend that internet connectivity to people that are beyond line of sight, that I actually have connectivity with, that may be outside of line of sight of that cell tower. And so really creating those layers. Another great use case that we like to talk about is teleeducation. Kids need to get coursework, need to turn in coursework. A lot of Zoom calls need to happen, right? Competing against telework and telemedicine options, right? But that teleeducation, all those things that I just mentioned really don't have to have the internet. But because of current infrastructure and the way the data is sent through that infrastructure, you have to compete against all those resources, just like I talked about with that text message, to get those services. And so again, I think that's a really good use case to go, hey, what if we kept it at the edge? We could keep it less latent, we could make it more secure, and we can start to solve the problem of these competing resources at these stovepiped network intersections.
So you also just briefly touched on security, obviously a huge and growing concern for everybody. Can you talk about the security dimensions of Osmosis and how you handle that?
Absolutely. There was a few pillars when we came from the military that we wanted to have. One was being multispectral. We didn't want to be denied in any one spectrum. Another big one was multi-level security. When you do an ad hoc mesh network, it's very easy to fracture when you start siloing information. And if you think about the way that we usually protect data, it's in silos. So from the ground up, we really built this network. And it's funny, we spent the first 9 months of the company, me and Matt eating ramen noodles and patenting all of our ideas. And this is one part of that, is the multi-level security. And so we really built a framework in which you can still flow data across nodes or devices that aren't able to process the information and keep that information flowing, to where you can have groups of security, as well as some of the future work that we're going to be doing in the near future is doing some metadata tagging to be able to have multiple levels of security within a message set, so that we're not over classifying or over encrypting data, which I know is a big problem right now, where, when DoD, for example, is in coalition type of environments, things get overclassified because they classify the entire message at the highest classification level, right? So being able to break that apart is something that we're really looking forward to doing next.
Great. Well, so that leads me to my last question, which was about what you sort of see as the next frontiers that you want to tackle, what the most exciting technical challenges are on your battle plan. So you just mentioned one of them. Are there others that you are looking forward to taking on?
Yeah, absolutely. On the technical side, we have quite a few. I think the nearest in is we're about to start a directed phase 2 SBIR with the Army under the XTech program, and really focusing on some JADC2 connectivity. Under that, we'll be starting our our PNT, so GPS services from the network without satellite reliance. And so that's one of the things that we're super excited about. There's a lot of other iterations that we have down the pipe where we're going to be doing more and more efficiencies. Some of that definitely is in the realm of dynamic spectrum sharing and some distributed MIMO type of capabilities. So we're really excited about that. We also look on the product side and see some next steps and challenges there as well. We've been fortunate enough not to just have a lot of traction on the government side, but also on the commercial. Surprisingly, even though we built the network for everything to be mobile, there's a lot of fixed wireless opportunities in tribal and rural connectivity that we're deeply rooted in right now. So just the chip shortage and figuring out how we're going to partner with other companies to bring the hardware to bear that we need to based on demand is really a challenge in and of itself that we're dealing with right now.
Okay, well, I really appreciate you taking the time to talk with me today. It's been a lot of fun. And if anybody out there has any questions, either for me or for Wind Talker, please get in touch with either me or Ryan. And Ryan, thanks so much for taking the time.
Thanks so much, Maren. Appreciate it.